So, welcome back to the next session of this lecture. So, in previous section, we were talking about some bands, frequency bands. So, I have told you there are several bands and radio waves having the lower frequencies and the frequencies increasing in this direction from radio wave towards the gamma wave. So, gamma wave is the highest frequencies signals and it is more dangerous. So, major equipments which we are using in our home, in our office, in our daily life is basically related to this microwave frequency band. And it starts from radio wave also. Some small frequency signals also comes to our homes, but the major concern will be related to the microwave frequencies. So we will discuss in detail. So this microwave frequency bands are listed here again. So let's start with the some applications. So in this section, we will start with the benefits of the electromagnetic wave. What are the benefits which we are having? Why we invented, why our scientists invented the electromagnetic wave? What is the need? How we are benefited with this electromagnetic wave, how we are using these waves in different applications. So let's start. So I have classified in several heads the application of EM wave. So EM wave, electromagnetic wave, is carrying energy, or we can say the message is being carried by the EM waves from one point to the another point. And you can see in these figures there is a satellite and it is broadcasting. So it is broadcasting signals to the several points. Here you can see sun is there, and we will discuss what is this figure. And it is satellite is going towards the Earth stations, and here one student is sitting on the computer, it is accessing the internet, and earth is related. On the earth we are using several number of applications depending on the electromagnetic waves. So in this figure you can see MRI machine is there, the doctor is holding a x-ray, and here you can see lots of AI based equipment. Electromagnetic is being used for these applications. And in the last figure you can see soldiers are using several electromagnetic wave based equipments. So lots of applications are there for the electromagnetic waves. So let's start. So first point is the communication. We use the electromagnetic waves in the communication. We use it for controlling the devices, controlling the equipment remotely. We do the remote sensing. We will discuss how it works for the remote sensing also. Several home appliances like we have the microwave oven based on the electromagnetic waves, and number of equipments are there in the medical science. We are using the electromagnetic wave based medical equipment devices there. And that is vision, means sunlight is coming to us and we are able to see several things. And electromagnetic wave, sunlight is also a type of electromagnetic wave, and various other applications. So we will discuss in this section. So let's start with the communication. So what is exactly the communication? So someone wants to send the signal or some information or some message from one point to another point. So that is the communication. We are transferring some information from someone to another one, or some point to another point. That is the communication. So in terms of engineering, uh, we refer it, two type of communication is there. One may be wire is there, means both transmitter and receiver are connected with the wired media, means there may be some optical fiber, there may be some other cables, coaxial cables may be there. So that is the wired communication methods. But the another advanced media which is being used nowadays by us also, that is the wireless medium, in which both transmitter and receiver are not connected to each other with any physical medium. So wireless medium is there. So how the signal is transferring? I'm talking on phone, I'm talking on mobile phone. How my receiver is listening my voice in the exact form? So it is happening due to the electromagnetic spectrum. I am accessing internet at my place and I'm sending the mails to the another place to the USA, and how it is being sent wirelessly. Within a second, it is being sent. So it is happening due to the electromagnetic waves. So we can estimate, we can sense how important these waves in our daily life. So we can classify further the electromagnetic use of electromagnetic waves in communication. Like we are using the phone, maybe several type of phone may be there. Then I mention here the mobile phone, because mobile phone carries several type of applications within it. We are using the Wi-Fi, we are using the GPS, we are using the Bluetooth, and several type of applications are there. So calling is there, text messaging is there, emailing is there through the phone. Several type of applications we are performing, and all the applications are based upon the electromagnetic waves, transfer of electromagnetic energy. And the second point is the satellite communication. Satellite communication, we also use the electromagnetic waves in the satellite communication. Several applications are depending upon the satellites. We place the satellite in space for controlling, for sensing several things, and we will also discuss in this section. So the next part is television, FM, radio, which is being broadcast. Electromagnetic waves are being used for these applications also, and data transmission through internet. So this is also happening through the electromagnetic waves. We are using the electromagnetic waves to transfer the data through internet also. And the second part, the last part is the Bluetooth. So we are having several type of equipments, like we are transferring the data through the Bluetooth. Means some video file may be transferred from one mobile to another mobile. We are using the Bluetooth speakers. We are using the Bluetooth microphones, and Bluetooth based several devices are there. So Bluetooth signal is an example of electromagnetic waves. So several applications are there. So let's discuss one by one. Few of them may be discussed because there are lots of applications. So we will only discuss few applications, few of them. So electromagnetic waves. So we have talked about the spectrum. Spectrum means what is the frequency categorization of the electromagnetic waves. So we are having two type of options. Means we may use the lower frequency signal. This signal is the lower frequency signal. Even the amplitude is the same. Amplitude is the same for both the signal, but this is the lower frequency signal and this is the higher frequency signal. So in communication, we need the modulation, and we need the high frequency signal. Then what is the need of high frequency signal to transmit our communication? The first point is to increase the range. Suppose I would like to give you one example. If I am speaking in a ground, so my voice will go up to few meters. It cannot go beyond that limit. So if I want to put my voice on a larger extent, so I should use some methods. I may use some methods. So that is some type of modulation in the communication engineering. So what we use, suppose this is our message signal, and so we use a carrier signal, and we modulate the carrier signal as per our message signal, and this will be the modulated signal. This signal will go into the space, and this will be radiated through the antenna. So high frequency signals increases the range of the communication, so it is being used. Second point is the height of the antenna. Height of the antenna may be related to the lambda by 2 or lambda by 4, as we have discussed in the previous section, depending upon monopole or dipole antenna which we are using. So height of the antenna is also related lambda by 2 or lambda by 4, and lambda is related to the C by F, we have already discussed. So if you are using lower frequency, then height is required, means length of the antenna is required higher. So if we are using the higher frequency signal, then height of the antenna will be reduced. That is also a benefit for using the higher frequency signals, because a very large size of antenna is not feasible to have, and we need compact devices. So earlier we were having a larger size of mobile phones. Now we are having small phones. All things are being compact. We are working on the miniaturizations. So we are also moving towards the high frequency. So that is also a requirement for the high frequency. The second thing, next thing, if we will talk about the improves quality of reception, means if suppose we are transferring lower frequency signals, and on the other hand we are transferring the high frequency signals, so the reception quality of the high frequency signal would be better. And the next point is the avoid the mixing of the signal. So while dealing with the low frequency signals, there is a interference, high level of interference will be there. So if we are using the high frequency signal, then our signal will be good quality. There will be a loss probability of the interference symbol. Interference isi would not be there, and interference will not be there, so our received signal will be good. Otherwise what will happen, I'm saying something, and the receiver would not be able to receive it as it is in current form, as it's in actual form. So reception or regeneration of signal is also a main thing. And the next point, allow the multiplexing of the signal. Several type of signal may be multiplexed. Suppose an example is there. There is TV, and one thing is FM. So in FM we are using the audio signals, but in TV we are observing the two signals, means a video signal is there and a audio signal is also there. And in this PPT also I'm talking, and I'm showing my video also. So that is something multiplexing of signals. So we are sending the video signal, we are sending the audio signal. So multiplexing of signal is possible with the high frequency signals. Otherwise in the previous scenario we were only able to send the AM signals. We were using the radios, and the later stages with the advancement of the technology we was able to use the TV. So that was possible due to the high frequency signals only, and because we were able to use the multiplexing of the signals. And bandwidth adjustment, several bandwidth adjustment is possible at the with the high frequency signals. So that is also the need of high frequency signal, and we can say the modulation, we are performing the modulation for it. So that are something which need to know what is the need of high frequency signal. So someone say, because in the later section of this lecture we will discuss about what is the hazards of the high frequency signal. So we need to know what is the requirement, what is the need of high frequency signal, why we cannot deal with the low frequency signals. So that is the need of the high frequency signal. It is demand of the society, it is demand of our need. So let's discuss few mode of the communication. So here you can see a satellite transmitter is there, and here in space satellite is fixed over there, and it is sending the signals to the satellite, and satellite is sending the signal to the receiver. So this is the function of the satellite. And again, so this is the mode of communication, satellite communication we may talk. And second thing is the microwave links. Microwave links, you can see here, this is like a mobile tower. Mobile tower you have seen around you. So this is one mobile tower, this is second mobile tower. First mobile tower is sending the signal or receiving the signal with the second mobile tower. So the link is established, and it is referred here as the microwave link. So third example of the mode of communication is the radio. So it is broadcasted over there. So a number of receivers may receive the signal which is being broadcasted. So receiver 1, receiver 2, receiver 3, receiver 4, all of they can receive the broadcasted signal. which is broadcasting on the FM or radio signals. And this example is also there, telephone line, that was some obsolete method. So in this I have talked, that was the physical media, means transmitter and receiver is connected with the physical media transmission line. So that is the example of physical communication. But above three examples are the examples of the wireless communication. So in these examples we are using the electromagnetic waves. And let's move further. So now let's talk about the satellite communication. So I have given you some idea about the satellite communication. So let us discuss in some detail. So you are observing here there is a transmitter. So satellite is basically working as the repeater. Repeater means what is the need of satellite, why we are not transferring this signal from transmitter to this receiver. So this is happening due to the curvature, earth curvature. So our earth is curved. So suppose we are here, our earth is curved like this, and we are here, transmitter is here, so and receiver is here. So we are not able to send the signal directly. Direct link is not possible between the transmitter and receiver due to the earth curvature. And second thing, the distance may be there. Third thing, if we want to broadcast our signal, broadcast means suppose this thing is the broadcasting, means satellite is receiving a signal from one point and it is broadcasting to more than one point, means more than one receiver is there. So that is the broadcasting example. You can consider it as an example of broadcasting. So the need of satellite is clear here. And I told you it works as the repeater. What is the meaning of repeater? Means it is receiving the signal, and when it receives the signal, the quality of the received signal is not so good. So if it will send the same received signal to the receiver side, so the quality will be further degraded. So the reception would not be fruitful, and maybe there will be no fruitful results. So what the satellite do, it receive the signal, it regenerate the signal, and signal is being regenerated at the satellite point, and then it transmit to the receiver side. So satellite receive the signal from the transmitter, that we can say earth station, and this is the uplink. Uplink frequency is different from the downlink frequency. And then the satellite, after receiving and after regenerating the signal, satellite transfer the signal to the receiver side. That is the one application we are talking. There are lots of application of the satellite. We are just talking communication through satellite. Okay, so that is the one application. So we can see, we can observe how satellite is helpful for the communicating with other people, so for the broadcasting. And these signals, what are these signals? These are the EM signals. What are these signals? These are the EM signal. Electromagnetic energy is being transmitted towards the satellite, and electromagnetic energy is being sent back to the receiver side from the satellite. So all the things are happening with the help of electromagnetic energy. So this is again an example of satellite. So it is for the internet, and the phenomena is like same. And I would not discuss the architecture of the internet. Means we are connected with some nodes, and nodes are connect further nodes, and then our country node will be there, then countries are interconnected, and then like we send the signal or we receive the signal through the internet. So there is a defined architecture, we are not going to discuss it. So we are just showing the applications of the electromagnetic field. So it is happening like this. Means we are sending the signals towards the satellite, and we are receiving the signals, and internet is working, local area network is also working, means you are using the Wi-Fi over there or something like that, and we are using the electromagnetic waves for these applications. Then again, need of satellites, you can see here, like it is also the same examples. We are sending or receiving the signals from one hub, and we are again broadcasting that signals, and that is being sent by these indoor units, and we can call it the Wi-Fi router towards our computer, laptops, and all the happenings is done. All the transfer of signals, transfer of information is being happening through the electromagnetic waves. Here, all the electromagnetic waves are involved. Means we can see, we can assume we can't live without having the internet, and it is being operated with the help of electromagnetic waves. So our life is dependent on the electromagnetic wave. So now we will see the applications of electromagnetic wave in the remote controlling. Remote controlling is something what we are not connected with our object physically, and we are controlling it remotely. So in the first figure you can see that is a drone, and it is used in the defense application majorly. So here you can see camera is being operated, and it's these fins are connected, and it is operated, and this can be operated through a remote, and the person who is handling the remote would not be there with the this drone. So it is happening just because of electromagnetic signals. And in the second uh, picture you can also observe second type of drone is also there, and one person is uh, flying that drone with the help of this remote, and the information is being sent from this remote to this drone through the electromagnetic signals. And if this camera installed on the drone capture some information, and it will send again, transmit again the information towards its hub. So the information is being sent through the electromagnetic waves again. So EM is being used for the remote controlling. And you can see the one more type of drone here. Camera is also installed here. You can see the rotation of camera is also being handled by the remote, and it is flying. So EM is also useful here. So now let's talk about the remote sensing. So in this figure, you are observing a satellite is placed here, and it is doing some sensing exercise. Means it is scanning our globe, our earth. So what is it doing? So several type of applications are there. Weather prediction is also there, and several things are being observed. GPS is also working, and our maps is also being tracked. Imaging is also being tracked by this sensing, and all these things means there may be some earth station like here maybe, and they are operating this satellite remotely, and EM is involved. Then this satellite is capturing some data from here. So for capturing the data, it is sending some signals, then some reflection is coming there. So all thing is happening through the electromagnetic wave. Then after receiving these data, this data is being again sent to the earth station. So it is also happening with the electromagnetic field. So you can see what is the importance of electromagnetic waves in our daily life. So let's see remote sensing in detail. So please see this video. There are two type of remote sensing through the satellites. So we will discuss in next slide, and please see this video how the remote sensing is being done. And you can see this is the satellite. These are the solar panel, because in space satellite moves with the solar energy, because there is an ample amount of solar energy. All times they receive the solar energy, and they can generate the electricity, and satellite use that energy as a fuel. So you can see how the remote sensing is being done. So you can see next type of figure you would like. So like this, we can cover the uh, earth, and we can sense several information. What will be the weather condition, what will be the map, and through GPS all of us have used the satellite view. If you have not used, so please go in your map section in your phone, and then click on the satellite view. So you can see what is satellite is capturing, and even you can see the nearby vehicles when you are moving on the road. You can see what is the nearby vehicles moving in real time around you. So that was one type of remote sensing. One more type of remote sensing is there. Sun is there, and its satellite is being played. So majorly there are two type of remote sensing. One is the active remote sensing, and second one is the passive remote sensing. In passive remote sensing means sunlight is going there, and then electromagnetic field is being radiated, and then it is observed, it is sensed by the satellite, and then the related information will be sent back to the earth station. And the active remote sensing means some EMF is being radiated by earth itself. So the EMF is sent directly, and the satellite send the information. Or uh, there is no reflection and sun involvement in this active remote sensing. So we can see this figure and we can understand. So the sun is here and it is sending several type of uh, lights. Means the light is striking on the clouds, and the some EMF. So you can see here the incoming EMR, electromagnetic radiation. It is EMR is being reflected from the clouds, and it is sensed by the satellite. So we may predict about the weather, what will be the weather condition. So it is the reflected EMR is shown here with the red dotted lines, and that was some the active type of sensing. Means our trees, our buildings, they are emitting several type of EMR. Means they are radiating some EMR, inbuilt EMR type, and they are just direct sending the EMR towards the satellite, and satellite the sensing these type of EMR. Okay, so two type of remote sensing is there. One is the active, and second one is the passive. So you can see this figure also. So such type of indirect remote sensing. So the sunlight is coming over there, and the electromagnetic radiation reflection is going towards the satellite, and then after collecting the data, this satellite is sending the information to the earth station. So this is the remote sensing, and it is happening just because of electromagnetic field. Electromagnetic field is being used. Sunlight is also is a type of electromagnetic field. Now, let's talk about the next application, that is radar. Radar is the radio detection and ranging, and you can see here, you can start it here. Means it sends amount of signal towards the target. So if there will be no target, so this signal will go into the infinite and no signal will be reflected back. But if there is a target, so there will be the scattering of signal, and some amount of signal will go in different direction, but few part of the reflected signal go towards the radar side. So radar compare the transmitted signal, the blue signal transmitted signal, and the received reflected echo red signal, and it compare both type of signals. Phase calculation will be there, and it estimate what would be the length of the target. Means distance of the target, what would be the distance of the target, what would be the speed of the target, what would be the direction, what would be the other characteristics of the surface. So radar can detect several type of information about the target based on this phenomena. So such type of radar means we use. Means in this figure you are observing, it is sending the signal in one direction only, but it rotate like this because target may come from any of the sides. So we use such type of radar antennas. It is sending the signals again and again. So you can see here somehow a light very the light is the lines are not so bright here, so something signals are shown here. So it transmits the signals, pulse of the signal is being sent, then it waits for reception of the signal. Then if some echo is coming, then it will analyze, then and again after some time, after some intervals, it regularly sends the signal, transmit the signals. And the observation is on the PPI display. So that is the PPI display. So you can see here there is some target present here. So whenever it is rotating, so some target is present here. So it may be reflected on the PPI display. So that is connected to the radar, and there may be some stationary targets, means like mountain the high buildings. So we need to ignore such type of targets. So that is the radar, and radar is also working on the electromagnetic field and electromagnetic waves. So that is one more application of the electromagnetic fields. So that is radar. So now come to the next application, that is the home appliances. So number of home appliances is based on the electromagnetic field. So here you are observing smart TV is there, smart speakers is there, smart headphone is there. So it is connected with the Bluetooth, and Wi-Fi is connected with the mobile, and several signals are coming electromagnetic wave. Its tablet is also connected with the EM waves. Radio is connected with the EM waves, and cordless phone is connected with the EM wave. Wi-Fi router is connected, laptop is connected with the Wi-Fi. Light is also radiating some EM signals, lower frequency signals. Your socket is also radiating some EM signals. And in the window side, you can see mobile towers is also there, and some other signals are also coming from outside. So these are the home appliances. So more home appliances you can see here. AI based means all AI based signals are all items, all gadgets which are based on the AI. So it is being used by the electromagnetic, means you can operate all your home appliances through a mobile. So it is using the phenomena of the electromagnetic waves. It is using the electromagnetic fields, and all of us are known how it is connected to each other. We can operate. We are having the automatic door. We can operate the automatic light. Microwave oven is also working on the microwave frequencies. We can operate several of, we can on and off our refrigerator. We can on and off our several equipments, door lock, several security systems are there. So all the things are being related to the electromagnetic fields. So now we will see the application of electromagnetic field in the medical science. So several equipments are there. So you are seeing here the MRI machine, and MRI machine also using the electromagnetic spectrums, electromagnetic waves. Now this is the X-ray machine. X-ray frequency is also based on the EM field. EM electromagnetic phenomena is there. These are the dangerous, and I have shown you the uh, table of the frequency and the wavelength. So MRI and X-ray machines are based on the high frequency equipment. So these are very dangerous. So their exposure should be limited. Their exposure should not be very high, and the frequency should be minimum. So these are the medical equipment, but it is necessary for the needy persons, because if someone is ill, someone is suffering from some disease or some accident, so we need to diagnose them. So these are very helpful equipment for the human being, for the life of the human being, and it is necessary, and it is based on the electromagnetic field. Now if we will talk about some more applications of the medical science which is dependent on the electromagnetic field, that is the implantable devices. Implantable devices is something what which can be implanted within the body. So like the pacemakers, uh, we implant it for the heart surgeries, and some type of brain stimulators, neurostimulator, gastric stimulator is fixed inside the liver or something here, and food drop implants, and several type of medical equipment are based on the electromagnetic field theory, because they send some signals for monitoring, and it is dependent on the electromagnetic signals. And implantable device, you can see several type of implantable devices is there. So there is a small microprocessor is there, battery operated are also there. So nowadays we are having mm, we are reducing the size of the implantable devices. So scientists have reduced this battery part also, and some small part of antenna is also there for sending the signal, because monitoring is also necessary for such type of devices, and these signals are being transmitted through the electromagnetic fields. So the need of electromagnetic field is clear. I think it should be clear to you. So such type of uh, devices, smart pills are being used. So that was MIT researchers involved in this research, and they involved some smart pills which don't use some battery parts. So I have shown in previous slide. So such type of smart pills will be there for a few for a time period, then it will be dissolved inside this inside your body. So the time period, the life of the device is fixed. So the scientist made that device which is necessary for such time. So it is for the medical science. I'm not from the biology background, so my knowledge is also limited for this field. So I'm just talking about the use of electromagnetic field. So let's discuss the further applications of the electromagnetic field. So that is the wearable technology. So you are seeing here an soldier, it is wearing the smart eyewear is it can capture something, means maybe some camera may be there, some GPS may be there, data readout is there, and it can collect some data and it can send data immediately to its reporting head and its unit. So such type of smartware is there. So if it will send the data, if it will sense some pictures like this, so how, and some object will be there and reflection will be there, so these signals will be the electromagnetic signals, then it will send the data to its monitor or its unit. So it will also be the electromagnetic signal. So such type of devices are there. Smart textile is also there. So smart jacket, it may also include the GPS is also based on the electromagnetic signals. Smart keychain is also there. Smart tattoos is also there. Wearables is also there, means the biomedical data, means we may use some smart watch, cardiac monitoring, temperature, performance, means what is the temperature of your body and what is your heartbeat, what is the other things. You can wear a smart watch or smart bands are there. So it works on the electromagnetic field. Several type of Bluetooth connected devices are also there. So I have told you Bluetooth is also based on the electromagnetic field. So now see other variables like smart ring, smart glass, smart shirts, smart watch, Bluetooth key tracker, smart shoes is there, smart socks is there, smart pants, smart belt, baby school, GPS inbuilt baby school, smart bracelet, smart fingers, means which is smart, it is based on the electromagnetic field. So most of the smart thing. So this is the beauty, or we can say how much important this electromagnetic field in our daily life. So here we can see some type of smartware also, and sports in different fields. We are using these smart technologies, and most of these technologies are based on the electromagnetic field. So we can see here business operations we are using, security and safety we are using, medical, wellness, luxury of life, sports, fitness, lifestyle, communication, glamour. So in all the sectors, we are using the smart technologies, which is based on the electromagnetic field. So here we would like to end this section, second section, and in the next section we will start, and we will discuss the hazards. What are the hazards of the electromagnetic waves? So here we end this section. Let's meet in the next section.